Today we're going to look at characteristics of function graphs. To start out, let's take a look at this graph here. So it appears that we're coming from all the way down here. Let's say that this continues going this way, and we're going to go up to the point 3, 0, and then we're going to start going back down to the point 5, and it looks like negative 1 1/3 or negative 1.3 repeating. We go up past 6, 0, and we continue going up and to the right. So let's ask a few questions about this graph then. Are the values of the function on the interval from negative infinity to 3, so these are the x values here, negative infinity, less than x, less than 3, are they positive or negative? Well, this means that the points coming from way out here in negative infinity would be down here. Going from left to right, we are all negative all the way through that entire interval. So from negative infinity all the way to 3, 0, or just before 3, 0, all of these points are negative, or all these values of the function are negative. Okay, what about 3 to 6? So x is 3 to x is 6. From 3, let's see, we're going down here under the x-axis though, and then coming back up, but to that 6, 0 point, all of these values are also negative. So these are also negative. Okay, what about from 6 to infinity? Let's take a look again. From 6 to x is positive infinity. So we're going way out here. It looks like we'd be going up. All of these are going to be positive. So when a question asks you whether something is positive or negative, it's not asking whether it's going up or down necessarily, because here, from left to right, we were going up to 3, but we're negative because we're below the x-axis. So all these values are negative. From 3 to 6, we went down and then we went back up a little bit. All of those were still negative because we're below the x-axis. And then here, from 6 to infinity, positive, not because we're going up, but because all of these values are above the x-axis. They're above y equals 0. So let's talk about the going up and down then. Increasing, a function is increasing on an interval if f of x1 is less than f of x2, when x1 is less than x2 for any x values x1 and x2. Okay, so that sounds fairly complicated, but in easier terms, it's basically saying from left to right. If I'm looking from a point on the left and I'm following the graph from left to right, if I'm going up, then I'm increasing. Okay, decreasing, a function is decreasing on an interval if f of x1 is greater than f of x2, when x1 is less than x2 for any x values x1 and x2. Again, this terminology fairly complicated, but in other words here, this is just saying from left to right, if I'm going down, then I'm decreasing. So let's draw a little picture here. Let's say I've got the following graph. Okay, so I would say from negative infinity, x is negative infinity, to whatever this is. Let's say that that's negative, let's say that's negative 1. I would be increasing. And then it looks like I would be decreasing from negative 1 to right about 0. And then from 0 to, let's call this 2. From 0 to 2, I'm going up. So I would be increasing, and then from 2 to positive infinity, I'm going back down. So that'd be decreasing. So let's take another look at that same graph here and determine where we are increasing and where we are decreasing. So this question says, for the interval x such that negative infinity is less than x less than 3, is the function increasing or decreasing? So this is saying from way out here. Now the function is actually going to be down here, but negative infinity going left to right to 3 here, we are going up. So this would be increasing. Then it asks, what about from 3 to 5? Okay, so from 3, x is 3 to x is 5, following left to right, we are going down. So this would be decreasing. Okay, and then it says from 5 to positive infinity, are we increasing or decreasing? So from 5 and left to right, now we do hit this 6, 0 point, but I don't care about that. I'm just going to keep going to positive infinity. It's going to be way out here, and the graph's going to be up here. So from left to right, I am going up, I'm increasing. So what does this mean? When I'm asking about positive or negative is simply, is it below this x-axis or is it above this x-axis? If it's below, the values are negative. If it's above, the values are positive. But increasing and decreasing have nothing to do with where the points actually are located and whether or not they're above or below that x-axis. This is simply saying from left to right on that interval, are you going up or are you going down? If from left to right you are going up, you're increasing. If from left to right you are going down, then you are decreasing. And then here again, just in this graph specifically, we are increasing one more time. Let's talk about the average rate of change. The average rate of change is the ratio of the change in the function's values, so this is the vertical change, to the change in the x values. This is the horizontal change. This is often referred to in a number of different ways. Sometimes it's some people refer to it as how steep the function is at a certain point, or some say the change in y over the change in x. Some might just refer to it as the vertical change over the horizontal change. In all of those cases, the average rate of change is found using this: f of x2 minus f of x1 over x2 minus x1. Now, what does this mean? This is saying if you have 2 points of your function, then you can find the average rate of change between those 2 points. The first point is going to be x1, y1, or in this case, x1, f of x1, because remember, f of x, just function notation, is the same as y. And then x2, y2, or x2, f of x2, this is going to be your second point. So let's practice with this. Find the average rate of change for a function with the points 2, 4, and 5, 8. All right, pause there. Whenever I'm given 2 points, I'm going to label them. Let's say that 2, 4 is 0.1, and let's say that 5, 8 is 0.2. That means that this is going to be x1, and this is going to be y1. So x1 is 2, y1 is 4, and then x2, y2, since this is 0.2, 5 is x2, 8 is y2. Now let's use this average rate of change formula. F of x2 minus f of x1 over x2 minus x1. So f of x2, or y2, is 8 minus f of x1, or y1, is 4, and over x2 minus x1. So this is 5 minus 2. All right, 8 minus 4 is 4. 5 minus 2 is 3. The average rate of change is 4/3. Okay, let's do another one. Find the average rate of change for a function with these points. And again, the first thing I do is I just pause and I label these points. So this is point 1. I'm going to make this point 2. So this will be my x1, y1. Remember, y1 is the same as f of x1. And this is x2 and y2. And then I do y2 minus y1, or f of x2 minus f of x1. So that's negative 12 minus 1. And this is over 4 minus negative 3. Negative 12 minus 1, that's negative 13. Over 4 minus negative 3, careful here. Subtracting a negative, this is going to be positive 7. So your average rate of change between these 2 points for whatever function this is going to be negative 13/7. And lastly, we're going to talk about turning points or extrema. So extrema. This is a group of different type of points. Some of these are going to be maxima. Some of these are going to be minima. Maxima sounds a lot like max, maximum. These are going to be the high points of the function. Now, I want to differentiate a local maximum versus a global maximum. A local maximum might occur when switching from increasing to decreasing. It can also occur technically if you just have an endpoint that isn't the highest point in the function. And then a global maximum, this occurs at the highest point of the function if it can be kind of calculated. If the function is just going to keep going up and up and up, then you don't really have a global maximum. And we're going to see what that looks like. Now, minima, that sounds like minimum, and these are the low points of the function. So same kind of thing. A local minimum occurs when you're going from decreasing to increasing. So when you're going down and then you go back up. Again, this could also occur if we've got an endpoint that isn't quite the lowest point of the entire graph. And then the global minimum, this is going to be the lowest point of the graph if there is one to be found. Now, again, if this goes down and down and down and never stops going down, then you're not going to have a global minimum. And a zero, now this isn't really an extrema, but just thought I'd throw this out there too. This is where the graph hits the x-axis. This is where the f of x or y value is exactly 0. So what we're going to do is we're just going to take a look at this graph here, and I'm not sure exactly what function this is, but we're going to identify what the maximums, the minimums, and the zeros are. So let's start with maximums. So this is when I'm going from increasing to decreasing. So let's see, I'm going down, up, down, okay, up and then down. So going from increasing to decreasing, I'm going to have a maximum at that point. And let's see, I'm going down, up, and then this one's kind of tricky, but I'm continuing to go up. So this is increasing all through this interval here. So it looks like this is my only maximum. And remember, since this graph is going to continue going up over here and over here, this isn't the highest point of the function. This is just going to be a local maximum. All right, now let's identify the minimums. This is when we're going from decreasing to increasing. So when we're going down and then we go back up. So from left to right, going down and then back up, I'm going to have a minimum here. And then up, down, and then I'm going to go back up here. So from decreasing to increasing, I'm going to have another minimum here. And this is all increasing throughout here. So I've got two points to identify here. This one is not the lowest one. So this is just going to be a local minimum. whereas this point is the lowest point of the entire graph. So this is going to be a global minimum. Lastly, where are my zeros? My zeros occur when I hit the x-axis. That's when the f of x or the y value is exactly 0. So I've got a 0 here, a 0 here, a 0 here, and a 0 here. So all of these are zeros. So hopefully with this gives you a better idea of how to look at graphs and identify different parts of graphs, whether they're increasing, decreasing, or whether they're positive, negative, as well as what certain specific points on your graph are and what they're named.